Okay, let's talk about artificial intelligence. I mean, you hear this term, what, a dozen times a day? It's everywhere, in our phones, our cars, all over the news. But it can feel like this big, complicated, almost magical thing, right? Something you can't really pin down.
So, what is actually going on under the hood? Is it just a bunch of fancy code? Is it some kind of thinking machine? For just a few minutes, let's just push aside all the hype, all the sci fi movies. What are we really talking about when we say AI?
Well, that's exactly what we're going to do right now. We're going to strip away all the mystery and build our understanding of AI from absolute zero. I mean, from the ground up, starting with the simplest pieces. You ready? Let's do this.
The best place to start is usually the simplest one. And in this case, it's the name itself artificial intelligence. Let's just break those two words down.
Okay, first up, artificial. This one's super straightforward. It just means it's not natural, right? It's something made by humans, by us. Simple enough.
All right, now for the second part intelligence. And this is where things get a little more interesting. See, from a scientific point of view, intelligence isn't just about being smart. It's a whole process. It's the ability to get information, to reason about it, to learn, and then, crucially, to make decisions.
So let's put those two pieces back together. Artificial and intelligence. What do we get? We get a really solid scientific definition. Artificial intelligence is basically the whole field of study, the engineering of systems that can do all those intelligent things we just talked about. Perceive their environment, reason, learn from data, and then take action to hit some kind of goal.
Okay, so you might be thinking, how is that different from, I don't know, Microsoft Word? That's a piece of software, right? Well, the difference is absolutely fundamental. It's a massive shift in how we even think about building software. And this right here, this is the core of the entire revolution. Think about it. For decades, programming was all about humans writing super specific rules for the computer. If the user clicks this button, then do that exact thing. But with AI, we totally flip that on its head. Instead of writing the rules, we give the machine a ton of data and a goal, and it figures out the rules for itself by spotting patterns. That is the key takeaway. We write the program, but the AI learns and writes its own rules. Now, this whole idea of a machine learning the rules on its own, it can feel like magic. It really can. But if you ask how it's actually doing that, the answer isn't magic at all. It's math. Yep, just math. Incredibly complicated, massive scale math for sure, but still math. So let's pull back the curtain a little bit. All of modern AI really stands on the shoulders of three giants, three main fields of mathematics. Think of these as the three pillars that hold up the entire structure. Pillar number one is linear algebra. The best way to think about this is like it's the universal translator for AI. Look, our world is messy. It's full of images and words and sounds. Computers, they only get one thing: numbers. Linear algebra is the toolkit using things called vectors and matrices to turn all that messy real-world stuff into numbers that a computer can actually understand and work with. Okay, pillar two, probability and statistics. The real world is in black and white, right? It's full of uncertainty, and AI is to deal with that. It almost never deals in absolutes. It's all about making the best possible guess. Probability is just the math that lets an AI say, you know what? Based on everything I've seen, I'm 92.4% sure that's a picture of a cat. It's the science of the educated guess. And our third and final pillar is optimization. Now this is the engine of learning. This is how the AI actually gets smarter. Imagine it makes a prediction, and then it checks its answer and sees how wrong it was. We call that the error. Optimization is the mathematical process of going back and tweaking all of its internal knobs and dials just a little bit, so that next time the error is smaller. It's this relentless process of minimizing mistakes. That's how it learns. Okay, so we've got our three pillars: linear algebra, probability, and optimization. We have the tools, so how do we actually put them together to make an AI learn something? Let's look at the different strategies. By far, the most common way is something called supervised learning. This is exactly like studying for a test with flashcards. You give the AI a huge pile of data that's already been labeled with the right answers. This email is spam. This one is not spam. This is a cat. This is a dog. Then the AI uses that optimization engine we just talked about to keep guessing and correcting itself until it learns the underlying pattern for, say, what makes an email look like spam. Then you have the opposite, unsupervised learning. This time, there are no flashcards, no answer key. You just dump a massive, messy pile of data in front of the AI and say, find something interesting in here. And using statistics and probability, it starts to find hidden structures and groups on its own, like discovering groups of customers who buy similar products, even if a human analyst would never have seen the connection. And finally, there's reinforcement learning, which is probably the closest to how you or I or even a dog learns. It's all about trial and error. In AI, we call it an agent. Try something in a virtual environment. If it does something good, like making a good move in chess, it gets a little digital treat, a reward. If it makes a bad move, it gets a penalty. And over millions and millions of tries, it uses probability to figure out a strategy that gets it the most rewards. This is how AI learned to master games like chess and Go.
Okay, so the engine that drives the most powerful AI systems today is actually inspired by, well, the most powerful computer we know of, the human brain. Let's talk biology for just a second. In your brain, you have neurons. A neuron gets signals from a bunch of other neurons, and if all those incoming signals add up to be strong enough, it hits a threshold and bam, it fires, sending its own signal out to the next guys in line.
The artificial neuron is just a little piece of math that copies that basic idea. It takes in a bunch of numbers as inputs, it multiplies each one by a weight to decide how important it is, and then it adds them all up. If that total sum is bigger than some threshold number, it activates and spits out a signal. That's it. At its core, it's just a tiny little calculator. So if one artificial neuron is so simple, where does all the power come from? Well, that's where the term deep learning comes in. It's not nearly as mysterious as it sounds. Deep just means you take those simple little neuron calculators and you stack them up in massive networks with lots and lots of layers, sometimes hundreds of layers deep, with billions of neurons in total. The first few layers might learn super simple patterns, like detecting an edge in a picture. And the next layer takes those patterns and learns to spot a corner. And the next layer learns to spot an eye, and on, until it can recognize a face. That's deep learning.
Okay, we've come a long way. We've built this thing from the ground up. We've got the basic definition, we've looked at the math behind it, we've seen how it learns. So now it's time to bring it all home and ask the big final question. After all of this, is an AI actually thinking? I mean, is it thinking the way you and I think? And look, from a purely scientific standpoint, the answer is no. What's going on inside these systems isn't consciousness. It's not self-awareness, it's not feeling emotions. What it is doing is all the stuff we just built up from zero. It is recognizing patterns, it's estimating probabilities, and it's optimizing decisions. It's just doing it on a scale that is almost impossible for us to comprehend. It's an incredibly sophisticated tool, but it's not a mind. So, let's wrap this whole journey up. If we put it all together, this is what we get. This is artificial intelligence, with all the hype and sci-fi stripped away. It's not magic, it's the mathematical and computational study of intelligent agents that learn patterns from data, that reason using probability, and that optimize their decisions to achieve a specific goal. And that's it. It might just be one of the most powerful tools our species has ever invented, and we've just seen how it's built piece by piece from absolute zero.